Hey everybody, this is part 2 of Z tests and single sample t-tests. So for this one, we're just going to do some practice problems and make sure that we are all up to date. So what I want to do first is review what these are, and we'll ask some questions and do some examples. So here's how it goes. A Z statistic is when we have a when we have a mean of a sample that we want to compare to the mean of the population. For this to work, for a Z test, you have to know the population's mean, the population's standard deviation, how many people you have in your sample, and that sample's mean. Because what we're going to do is we'll take the mean of our sample minus the mean of the population. We're going to divide that by the population standard deviation divided by the square root of n. So what you see is z obtained. That's the z statistic that we're trying to calculate. The mean is our sample's mean. So x bar obtained is the sample's mean minus the population standard deviation, that's mu. And then sigma sub x bar is sigma, that is the standard deviation of the population divided by the square root of n. A t statistic, now specifically we're talking about a single sample t. We'll talk about other t's later on, but a single sample t is the mean of the sample minus the mean of the population divided by the sample's standard deviation, which is divided by the square root of n. So for a t, instead of knowing the population standard deviation, we know the sample's standard deviation. Let's do an example. I think that CU Boulder students are more stressed than the population. The mean stress for the population is 5 with a standard deviation of 2. So in this particular case, we know that the population's mean is 5. The population standard deviation is 2. Already, we should know which statistic we're going to calculate, whether it's Z or T. Let's say that I take a sample of 18 CU Boulder students. Their average stress is 6. 18 CU Boulder students with their average stress is 6. Now notice that I don't have a standard deviation for the sample here, all right? With those pieces of information, what would be my Z statistic? All right, to calculate the Z statistic, we need to know several things. We need to know the population's mean and the population standard deviation. So the population's mean is 5 with a standard deviation of 2. So what I'm going to do is I'm actually going to open up a spreadsheet that I have which shows these things. So, sorry, losing my stuff there. Okay. So I'm going to open up this spreadsheet right here. And with this spreadsheet, what we're going to do is we're going to look at, move it over, we're going to look at the information that we have. So we are running a Z statistic. So this is the formula right here. So let's enter in the data. I had stuff from a previous thing before. So mu is the population's mean. So for this particular example, mu equals 5. All right, the population's mean is 5. Sigma is the population's standard deviation. In this particular example, that is 2. For our example that we're talking about right now, I sampled 18 CU Boulder students, so N is 18. And they have an average, X bar, their average, meaning the sample's mean, is 6. So when we look at this formula right here, X bar, right here, that's the mean of the sample. Their average stress is 6. I have 18 people. Okay, so that's n, 18 CU Boulder students right there. This is the square root of n and automatically calculated for me because I told it to do it before. Mu is the mean for the population, that's 5. And sigma is the standard deviation, that's 2. So x bar, 6, minus mu, 5, that equals 1, right? Divided by sigma sub x bar, and sigma sub x bar is sigma, that's the standard deviation of the population, divided by the square root of n. Sigma is 2 divided by the square root of n, which is 4.24264. When you put that whole thing together, we get a Z statistic. Our Z obtained is 2.12. Now, the question is, do we reject or fail to reject the null hypothesis? So we got this is 2.12. Do we reject or fail to reject the null? Let's assume that this is a two-tailed test. Should we reject or fail to reject the null hypothesis? To answer this question, you need to do the same thing we've always done. We need to look up the correct table. Well, this is a Z test, so we're still looking at a Z table. This is our Z table. Let's go ahead and put it over here on the side so we can take a look at things. This is slightly different perhaps than the one in your book, but it gives us the same information. So the area beyond Z, this is the smaller portion. It's the same as if it was a smaller portion. If this is a two-tailed test, then that means that we need to split that area beyond C, the area in the smaller portion, we need to split it into 2. And if alpha equals 0.05, then that means we need to have 0.025 in one tail and 0.025 in the other tail, which means that we are looking for this part right here, 0.025. The Z-score that has that is 1.96, and that's always the case. For Z, that's always the case. There's no degrees of freedom. It's always the same. It's always the case. And in this particular case, our Z obtained that we got was 2.12. That's more extreme than 1.96, so we can reject the null. Now remember, the entire point about this was my hypothesis was that CU Boulder students are more stressed than the population. So that's my hypothesis. The null hypothesis would be CU Boulder students are not more stressed than the population. There's no difference between CU Boulder students and the population in terms of their stress. In this particular case, the Z that we got was more extreme enough that we can say that, yeah, CU Boulder students are significantly more stressed than the population. By the way, I made up these data. They're not real. For our next example, this one. For the next example, let's talk about coffee drinking. I think that my students drink more coffee than the population. The average for the population is 3 cups of coffee per day. I actually looked that up on the internet and they said it really was 3 cups of coffee per day. So if I think that my students drink more coffee than the population, and I know that the average for the population is 3, then I measured 20 of my students. They drank an average of 5 cups of coffee per day with a standard deviation of 2, meaning that my sample of 20 students had the average of 5, and the sample of 20 students, the sample standard deviation is 2. So what test are we going to use, and how do we do it? So for this test, we are going to use a single sample t-test. And the reason why we're using a single sample t-test is because we know the population's mean, which is 3 cups of coffee per day, but we don't know the population's standard deviation. Instead, we know our sample. We know that we have 20 students, that's the n. We know that the mean for that sample is 5 cups of coffee per day, and we know the sample's standard deviation, which is 2. And when we know the sample standard deviation, but not the standard deviation of the population, we're going to use this t-test, a single sample t-test. So go ahead and let's calculate it now. So for this, we're not using the z-test. We are using the t-test over here. So we're using mean of the sample minus the mean of the population divided by S sub x bar. And S sub x bar is the standard deviation of the sample divided by the square root of n. So let's go ahead and enter these pieces of information that we have. So we'll calculate this in just a second. Mu that we have, and now we're talking about the cups of coffee, the mu is 5. Look over here, the standard, the average, I lied. Mu is not 5. Mu is 3. I apologize for that. The average for the population is 3. So mu is the average for the population. That's 3. Now notice that I don't have a sigma here because I don't know. For a t-test, for a single sample t-test, you do not know the standard deviation of the population. You only know the standard deviation of the sample. So let's get that information right here. I know that I have 20 students, so let's go ahead and do that. N is 20. The average for those 20 students is x bar, so that's down here. That's going to be 5. And the standard deviation for those students is 2. So what you see here is we have x bar, that is 5. That is the average cups of coffee for my sample, right? That's 5. Minus the average for the population, which is 3. So mu, right there, that's 3. Divided by the standard deviation of the sample. So the standard deviation of the sample is 2. Divided by the square root of n. N is 20. This is the square root of n right here, 4.47. So this is 5 minus 3 divided by 2 divided by 4.47. And when we get that, we get 4.47214. Now the question is, do I reject or I fail to reject the null hypothesis here? So the null hypothesis here is that my students don't drink any more coffee than anybody else. So what we're going to do is, this is a t-test, so we need to look at a t distribution. Let's go ahead and find that. So this is our t distribution. This is the level of significance for a one-tailed test. This is level of significance for a two-tailed test. The t that we obtained is 4.47. Now, just so you know, degrees of freedom is slightly different for a single sample t-test than is for the other t that we've been looking at. We looked at t previously with a Pearson's R, and that's n-2. When we're doing a single sample t-test, it's n-1. That changes. I'll always tell you on the exam what that's going to be. So in this particular case, we had 20 people in our sample, so the degrees of freedom we're looking at it for is 19. The degrees of freedom would be 19. So now we need to know whether or not this is a one-tailed or a two-tailed test. Normally we're doing a two-tailed test. So two-tailed test with an alpha equals 0.05. So here's 0.05. So we're looking in this column for a two-tailed test. Alpha equals 0.05. And the degrees of freedom of 19 is right there. The critical value is 2.093. So we have to get a t statistic which is more extreme than a 2.093 in order to reject the null hypothesis. So 2.093, the t that we got is 4.47. 4.7 is more extreme than 2.093, and so we reject the null hypothesis. By the way, if this had been a one-tailed test, then we would have been looking at 1.72 right over here. We would reject that anyway, right? So what that would mean is we're saying, hey, remember the original hypothesis, I think that my students drink more coffee than the population. The average for the population is 3. I put in all my other data for my sample. I would find in this case, yeah, I would reject the null. I would say that it seems like my students are drinking more coffee than the population based off of that. Final example. Now, I want you to think about this. Which test would you run? I think that taking tests makes people stressed. So I measured 20 of my students before the exam and then the same 20 after the exam. So their average before the exam was a stress level of 3 with a standard deviation of 1.5. Their average after was 4 with a standard deviation of 1. So what test would I use? This is a trick question. The purpose of a z-test or a single sample t-test is for you to compare one mean with the population. In this example, there is no population's mean, so you cannot run a z-test or a single sample t-test. You can't run either of them. This is what we're going to be working on really in the next step. That is a paired samples t-test, which is a different test. So you can't run either a single sample t-test or a z-test for this particular scenario. So make sure you know what test you're running and why you're running it. Those are important pieces of information. All right, good luck, everyone.